Thank you for joining. And this is the Exploratory online seminar number 58. Today, I'd like to present time series data, really about how you wrangle, how you do the data wrangling and then data visualization, and also using analytics to analyze the time series data. So before I get started, let me introduce myself. My name is Kan Nishida, CEO at Exploratory. And Exploratory is the company that we started back in the spring 2016 to democratize data science by building the software product or tool to make it easier to do data science. And also, not only building the tool, we realized that actually the knowledge and the skill to do the data science is also very important. So we've been providing the training and the seminars, including this, to share our knowledges and skills so that more people can get into data science and then understand their own data to make better decisions. So our vision is anyone should be able to make data-informed decisions. I think what we can do, what we can contribute is to democratize data science. And that's really the kind of guiding principle that we are doing the work every day. Okay. And then when we say data science, we think of the workflow, data science workflow. Like usually you start with business questions or business problems to address. So therefore, like you need to access the data first, and then usually the data is not clean or prepared, that ready for even visualizing, analyzing the data. So you want to do the data wrangling, and then you want to visualize or you want to analyze with analytics such as statistical or machine learning algorithms to understand the patterns and the trend in the data, so that helps you answer the original business questions. So you go through all this process, and then eventually you find insights. Then most of the time, like you don't work by yourself, so you want to communicate what you have found with other stakeholders. So that communication piece is also as part of the data science workflow. So Exploratory is to provide modern and simple UI to do these 5 things: data access, data wrangling, data visualization, and the analytics and the communication. Okay, so enough about our introduction. So let's get started. So Exploratory online seminar number 58, time series data, wrangling, visualization, and analytics. Okay, so I'd like to start with the data wrangling today and then get into other topics. Let's go step by step. So starting with the data wrangling. In the data wrangling area, I'd like to cover 3 things. And of course, there are a lot of things you can do or you need to do around the data wrangling area. But today, with a limited time, I'd like to focus on these 3 basic things that probably you will face when you work with time series data. Okay, so the data type. So when you open the Exploratory, first thing you see is a summary view. Let me just go to Exploratory real quick. So this is a sales data that I imported. There's a CSV data. Okay, and then when I look, through like each column is visualized and along with some summary statistics. Okay. And then when you see, like, here's a data type for each column, and then this one, order date, and looks like a date data. However, it says character. Let's go to the table view. The same thing. It's like it looks like a date data, but the character or data type says character. So it seems like this is something wrong, and we want to see there's a more presented as a date data type. So what that means is if this is character, and this is a date data type or date and time data type. Okay, so the problem of this kind of stuff, meaning if you had somehow the column, usually when you import the data, it detects the right data type, but somehow it fails based on how the data was presented in the original data format, data files. So in this case, if the data was presented or recognized as a character data type, then what happens is when you go to the chart try to visualize it, and then you assign those character data type data on the x-axis. Then what's going to happen is on the x-axis side, those values of that column being treated as a character. So this system doesn't recognize as date and time. So difference between date and time and character is date and time, of course, knows a natural order, such as February is after January, right? October is after September, even though the October is a 10, September is 9, but 10 is, of course, after the 9. But when you look at x-axis here, like it's sorted as sort of like the January, and then October, November, December, and then the February, because it's sorted by alphabetically, like 1, 2, 3, 4. Okay, and then another problem is that there's no sort of like interval in the character data type. Character doesn't care, right? But the date and time world, we care. So it's not like, like October, right-hand side at the bottom, there's an arrow, and there's like August 10, and the next one is August 13, and the next one is August 18. But between 10 and 13, there's 3 days. And between 13 and 18, there are 5 days. So we want to respect those like interval. Okay, so we want to make sure the data type is correct. In this case, a date data type. Otherwise, when you visualize, you ended up getting the kind of unexpected, chart or information from it. Okay, so if we set the right data type, then this is what you're going to get. So first of all, left-hand side, next to the data, column, you see various options, such as, like how you round the data and floor the data, or how you extract the component of the date information, like such as year and month and so. And also on the visual chart side, at the x-axis, obviously the data is sorted in the natural order that we expect in the date and time data. And also the interval or the duration is respected, right? So it's not because even when you have like an NA, when you don't have any value between the dates or the months, but there will be filled with space. Therefore, it's kind of like, all the distances is respected. Okay, so what are the data types in Exploratory to be date and time information, or for date and time information? There are 2 data types. One is date, another one is POSIX CD. POSIX CD, kind of like a confusing name, but POSIX is a standard for the Unix computer. So some kind of standard in the computer world. But what's important here is CT, the last 2 letters. C is calendar, time, T is time, so calendar time. And the T is the time, as it indicates, this one has a time information. So when you have the time information in that data, the POSIX CD is the data type that you want to get to. If you don't have it, then either way, it can be POSIX CD, it can be date, but most of the time, like when you import it, it automatically register as a date. But the main difference is that, okay. So when we look at this data, we have the order date and the shipping date columns, and then both of them are registered as a character. So we want to convert this to right data type, in this case, date. Okay, so from the column header menu, you can see when I go to the Exploratory here, from the column header menu, and there's a change data type. And underneath, there's a convert to date and time. And then there are a bunch of options. And once you get used to it, this is very obvious, but this is the first time you kind of get confused what this one is. This is really very simple. The first, you want to understand what that date information is. So date component is the year, month, day, hour, minute, second, only this 6 component. Okay. And then, so year is actually Y, and then month is M, and D is day. So for example, left-hand side, when you have the data like 2017-0101, like then if you assume this is like a year, month, day, and that means in this world, in the exploratory world, or the world of R, it's considered YMD. When you have time information, now like there's an hour, minute, second. So these are the components that you want to know. Okay. And then there is a function called YMD. This Y represent year, M represent month, D is day. Okay, and this function converts a given data, given character data or even numeric data, doesn't matter, whatever the data is, to date type, as long as the data is in order of year, month, day. And this turned out it's very, very convenient function. It's to me like my one of my favorite function because it's so intuitive. Because when you give the data in this function, and it actually doesn't matter what is the separating characters. For example, the 2015-10-01, or instead of the dash, you can have the slash or space or any other character. In extreme case, you can have even like some, letters or characters. It doesn't matter. All it matters is the order. So in this case, year, month, day. And what if like you have, time information? In that case, there's another function called YMD_HMS. And HMS represent hour, minute, second. And usually, like pretty much all the data, you never really get the data that mix up like hour, minute, second information. It's always somehow this part is always hour, minute, second order. Only the YMD part, especially like different countries have the different orders, sometimes starting from MD and then Y or something like that. So this YHMS case, same thing. It doesn't matter what is the separating data. So it can be column, probably most of the case column anyway. But if you have letters, it doesn't matter. The order is a key. And then when you have like data turn out it's like month, day, year, there's another function called MDY. Okay, and then like when you have time information, then MDY_HMS. So there's a bunch of functions to cover all these combinations you can access to. And that's how you want to access from basically Exploratory. So what this one is, when you go to change data type, and then under the convert to date time, and that what essentially like whatever you select, it is going to populate that particular function. Let's say this case, year, month, date. So like I'm going to go with this year, month, date. If you had the data only year and month, then obviously you want to select year, month. But in this case, I have a year, month, day. So I'm going to select this one, and then it populate YMD function. And inside there's a column name. There's a this is called backtick. And that is because all the data has a space between. That's why it's kind of using the backtick to support this like a space in the column name. If you don't have the space in the column name, you don't even need to have this backtick thing. Okay, so that's kind of weird stuff. But anyway, so I'm going to override with this. So this function is going to convert this data to data type. Okay, that's the expectation. So run, and then I have a new step. And then this column is being converted. Okay, so once it's converted, and then this order date column now it has a histogram, like how many rows. In this case, each row is order, sales order. So like how many orders were in each sort of section of the date. Okay, so before converting, it's each value being considered as a kind of just each value, but now like we can see it as a sort of like a continuous and also interval sensitive data. Okay, so once we get this, and then like I can go click on this chart button, and then like I can visualize it, right? So then like I have all these options showing up. And then right now, like I'm aggregating by the year, but I can aggregate by the month. I can switch between. Okay, and that's and then like x-axis being sort of naturally order, and then interval is respect, and so on. Okay, so that's one data type thing. So this is one area that like when you import, right after you import, you want to check almost like a first thing you want to do. Like data type is registered okay. Then you can start, all the visualization, analytics, and all the stuff. Okay, so for the data wrangling with the time series data, so another challenging, the common case is the data is not ready for visualizing. And if, for example, in this case, this is Apple mobility data. When you go to the Apple mobility page, you can just Google it and you can download mobility data by the state, by the country, all the information, and then how much, I mean, what's that? I think they compare with like last year's January 13th, and then what's the percentage up, percentage down in terms of like mobility by the traffic, walking or driving, and so on. Okay, so that's cool that they share this information based on how people use Apple Map. However, they add each date as a column. So like, I mean, today it's more important. I don't know how many days passed since that day, but the more data grows, and then like you have more columns. And this type of the data is hard to use when you want to visualize. What happens is when you have that mobility data like this, I would like to draw the line chart and see like how the traffic or how the mobility, goes up and down, right? And then in that case, I want to assign date column to the x-axis and the value to be y-axis and something like that. However, with this data, something like this, what it's going to happen is when I go to the chart, this is what I get. Under the x-axis, I see like every single column. In this case, we have like 539 columns. And then if I assign one of the column, then there's only one data point. So it doesn't really make sense. I want to have like one column that contains all those days. Okay. So the problem here is we have something called wide data. The wide data is the more data comes in, it will make the table wider. So more columns. It sort of expand to the wide, like horizontally. As opposed to wide data, there's another type of data called long data. The long data is the more data comes in, it will make the table longer, kind of a vertical direction, okay, the being added to the bottom. And then it turned out that when you want to visualize, it's most of the time, the long data is better or easier to visualize. So in that case, when you have the wide data like this, the first thing you want to do is transform to long data. And then like you can have much more flexibility in terms of like how you visualize this data. Don't get me wrong though, sometimes you want to have the data in a wide data format way, especially when you do the analytics, but something like a correlation kind of stuff. But most of the time, especially the visualizing the data, you want to keep that data in a long data, especially for something like this kind of time series data. The time series or date or month, whatever is present in the columns, the first thing you want to do is convert to long data. Okay. And then once you do it, then like you can assign date column to x-axis, and in this case, sales column to y-axis. Then you have, this is not sales, probably the value if it's Apple mobility data. But then like you can just visualize the trend. Okay, so let's take a look what that means in Exploratory. So like here's Apple mobility data. Okay, and then you have this summary view. And as you see, like each day is presented as a column. And I have like 539 columns. Let's go check the under the table view how the data is presented. So I'm going to just hide the left-hand side. And then when you have like a lot of columns, the performance is not as great. But here it is. So like each day is presented as a column. So what I want to do is I want to something called gather, but I want to gather all the columns and to just one single column. So how can I do that? So I select one of the column, usually the beginning, and then like I can select the ending column, but I have to scroll all the way to the right hand side. So I'm going to just select whatever the columns I with the shift key. Okay, so like I'm trying to select all the columns except, I'm actually not doing it because I'm kind of like lazy. Like I don't want to go through all the to the end. But this is actually good enough because from the column header menu, and then there's a gather bracket wide to long. This is the one that do the magic. And underneath is select selected columns or selected range. I'm going to select this selected range because with this option, all I need to do is a starting column and ending column, and then all the columns between, instead of selecting one by one, right? So I'm going to select the selected range. When I do it here, range of column position. So if I selected the selected column, this could have been selected, and it is going to list every single column names. In this case, I don't want to list them like 500 some columns, right? So this range is good, and the start is January 13, and the end is February 10. And this is not the end of this data. That this data has way more, but I just selected only to here. So what is the end? I'm going to just all scroll down, and this one is the July 4th. I think this is probably the data I downloaded on the July 4th or something. So this is the last column of this data. Okay, and then I want to just squish it, make it long data. I'm going to just click on Run button at this point, and this is what we get. Okay, so now this is a long data, so that as more data comes in, and then it goes, longer and longer. Now I have the 27,000 rows, as opposed to before we had 539 columns, and whoa, this is really okay, and only 51 rows. This is like U.S. states plus DC. So like only 51 rows. But now after I gathered up the data, and then I have much more rows, but much less columns. Okay, and I don't like these column names, key value. So like I'm gonna just open this, gather step. And then here, the column name, I'm gonna select, this is like a date, and this is a value, and then click Run button. And then I got this information. Okay, so that's gather. And then like once I get this one, then like I go to the chart, and then I got use the line chart on something, and then x-axis. Ooh, I see all the columns. Why? Because right-hand side, this pin button is still pinning to the first step, which is a wide data. I want to use the long data after I did that data transformation. So I'm going to move this pin button to the second step. Now, whatever this chart is going to use is going to come from the second step, which is the long data. And the x-axis, I'm going to select date. Ooh, you remember when you see this A icon, that's not good, because this this data supposed to be date, but it says character. A is actually the icon for the character data type. So what's going on here? So when I go back to the table view, see this one, it says character. And I want this column to be date because, like I show you, I couldn't visualize the way like we want to understand in a natural way. So I'm going to convert this one, change data type, and then convert to date time. And in this case, again, it's like a year, month, day order. So I'm going to select this one and then click Run button. And now I got the date column. And then go back to the chart. Again, the pin button is still in the second step, but like I want to visualize the third step after I converted the data type. And then select here it is. Now I see the calendar icon, which shows this is a date and time, or in this case, the date data type. So select the date. Then I have this like aggregation level. So instead of a year, maybe let's say like I want to see like a weekly level. And the y-axis, I'm going to select the value. And instead of the sum, I'm going to select the average or mean. And this is the sort of like a mobility. This average of all the 51 states. But I can see like how that mobility goes up and down. Okay. And then, okay, so let's go to the next topic, which is, one another thing. When you have the date information like this, and in this case, I don't have to, but another thing that comes up in data wrangling often is how I can sort of like round this data. When you visualize, we are actually doing it here. This one, it says round, but in this case, week, that means it's always like a first day of the week in this case, right? So like month is probably easier to explain. So here is May 1st, right? So but even like May 1st, 2nd, 15th, 18th, all those days will be considered as May 1st. Okay, the same thing for June and July as well. And when you use the chart to visualize, then you don't you use this one. Sometimes you have to do as a data wrangling, especially when you're joining with another data set or data frame, and then target data has only like, let's say May 1st and then June 1st and then July 1st or something like that. And then when you want to join it with this date column, you want to convert this data to be all the January days to be January 1st, all the February day to be February 1st, or so on. In that case, from column header menu, there's a round. Okay, and then there's three types of the round. It's similar to basically the same thing with the numerical values. Round is up from the 1st to 15th, considered to be first of the month, and from 15th, I mean precisely. Actually, from 15th to whatever the end of the month will be considered to the first of the next month. Okay, and then this floor is all the days will be considered as the first of the month, and the ceiling or seal is basically the opposite. Okay, so any days will be considered to be the first day of the next month. In this case, for example, like if I want a floor and then like I want to do by the month or something. And I can select this one, so floor date, and this will do the flooring conversion. In this case, I don't want to override just because this is just for the demo sake. So I want to create a new column and then just name it as a date and floor or something. And then you get all the January day becomes January 1st. Okay. So that's the flooring, and there are other options as well. We don't have enough time for but you can just go to our how-to page and then check out other options here. So let me quickly. So I have done an online seminar for like data wrangling for data visualization. So I cover this kind of transforming white data to long data, or converting the text data to the date, and the other rounding option and so on. So if you're interested in, you might want to check out past seminar. You can find the past seminar from our homepage under the Learn and go to the online seminar page. And then you see the past recording, and then you click that, and you can find those information as well. Okay, so let's move on to the visualization. Visualization, a couple of things. We have done already some of the stuff, but let me just go one by one. First, mainly, you want to use a bar chart and line chart to visualize this type of time series data. This is not the only ones. There are other chart type as well, but this is sort of like a very typical chart types that help you visualize time series data. And how you when you use bar chart, when you use line chart. So the strength or point of using the bar chart is this bar chart is really about the height of each bar. So what that means is you can compare among the bars. For example, when you pick like two bars, and you can see like how bigger of this bar compared to the other bar. For example, 2 times or 30% bigger or higher, right? So like it's very easier to compare among all those bars. When it comes to the line chart is not really about how much bigger or how much shorter or smaller. It's about the sort of trend, which direction the line is moving. Okay, so this will give you, hey, this is like an upward trend or lowerward trend, or maybe like changing the trend at this certain point from the going up to the going down or something like that. So depends what you want to understand, what kind of pattern or trend you want to see, then you can pick and choose between bar and the line chart. Okay, so most of the time, like we use a line chart. So like I want to here, I like to see the trend. So let's say like you can select the line chart. Let's take a look at this one. Where the second, here's a global sales data. And then I'm going to use this order date. and then try to understand the trend of this information, the sales information. So again, like this is a bar chart. I'm going to quickly change that to line chart, and then change the aggregation level to, let's say, like a monthly or something. Okay. And then y-axis, I'm going to select sales. Oh, by the way, this sales, again, is a data type A. That means a character. And I want to, sales supposed to be numeric, but somehow it's a character. So here, and this can happen because there's a dollar sign in that data. So the system thinks this is a character, but we human thinks, hey, this is numeric, right? So I'm going to change the data type to numeric here, and then click run. And then now we have all sales as a numeric data type. Okay, so that when I go to the chart and then move, oh, I don't have to move the pin button because that new transformation, the data wrangling thing is considered is the same step. So under the y-axis, I'm going to select the sales and the sales sum, and that looks good. So here it is. I have it seems like a sales is kind of like a going upward trend. And from here, I can also do is showing that, for example, the trend line. Okay. Oops, what's going on here? Here, trend line. I'm going to click on trend line. And then there's a couple options. One is a linear regression, which will draw the straight line. And this straight line is really try to draw to make sure the line, the distance between the line and every single dot, in this case, this kind of data point right here, this point, the distance becomes minimum. So it's almost basically intuitive way of saying is like the line is going through the middle of all the data points. Okay, and another one is useful is this like lowest and gam. This basically do very similar. It's doing the same thing. It's just algorithms behind the scenes are different. But what it is it makes it more flexible to make the distance to be minimum. What that means, kind of dissecting or split, create a smaller section, and then make sure sort of like try to fit each line to be the actual data. Okay, so this one represents it's more, the kind of there's a trend that is actually happening instead of like a straight line. Straight line is like once you go up, it's always going up, right? So, but sometimes it's not like in the constant way of going up. Maybe like in this particular data, it seems like the sort of like upward trend change here. So it's like it seems like a going up. So like sales increasing way more than in the last 3 years, right? So like this kind of trend, I prefer using this polynomial lowest algorithms to fit the trend line to the data. Okay. So that's that. And then another thing sometimes happen in this kind of data is, so I'm going to just remove this trend line for now. So this is like a 2017, 18, 19, 2020, right? So these 4 years. I want to compare year by year. How is that like sales is increasing? Is that like we know right now that 2020 sort of like sales is higher than probably the last 3 years. And it seems like that way. And is that so? And also another thing is like, let's say like every August, every December is higher than the last, that year before. I want to compare those, this trend by year by year. What do I mean by that? So let me just quickly show the chart. So here, this is what I mean. Okay. So each color is, here it is. So each color representing each year. And then basically I stack them together, right, from the in the vertical way. And then, but the x-axis is the months. So this way I can see sort of compare by months, each month. So let's say like most right-hand side, the December. And I can see, okay, like a red color is way higher. So like looks like we're doing good in the December, not only December, maybe like from September to December or something. So how can we create the chart like this? This is very typical chart you sometimes see often. Okay, so first thing is let's change this x-axis to months level. Right now is the option we select is a month, but this is like a round months, right? So what that means is it has a year and a month and day component. It's just a floor to the first day, okay? But I want to extract only the months. Forget about the year, just the months from January, February, March. So that is, you want to scroll down to the extract. And then like you have three options. I'm going to select the short name version. What it's going to do is like from January, February to December. There is no year information. So what that means, for example, this November includes those 4 years of the information. Okay, so now I want to separate this line to each year. Okay, so then by using a color, then so I can select all the date again, and then here it is. I already have that. So right now here, the legend, it says 2017-0101. That's because here is rounded by the year. I can just extract the year. Basically, it's going to do the same thing, except that like those 0101 information is just gone because now I extract only the year, get rid of the months and day information. But the visualization itself, the chart itself is basically the same. But this way, I can see like how the sales trends in sort of like a progress as the year goes by. And it seems like it's every year we are increasing the sales. However, this by looking at this red color, 2020, seems like from the August to December, rest of the year, the increase is like kind of going up massively compared to other years. So that's actually a good sign. But I think that's not the point. That the point is, so this is how you can sort of like see the trend, how the trend is actually changing by the year. Okay, so that's the visualization piece. And there's one more thing actually I wanted to cover is window calculation. Okay, so I'm going to just copy this one and then get rid of this color. And I'm going to go back to kind of month information here. Okay. So now sometimes you want to accumulate some information, sales information. And then, you know what, actually, let's use this one. This is good. So this one is like every single year, like I have the trend and I want to accumulate. And then so that like by that, for example, by the July, how much of the sales we have made. And by the August, how much of the sales in total we have made in this year. So that's the kind of numbers that I want to visualize. In that case, you go to the y-axis and then there's a quick window calculation and there's a cumulative sum. And then you can actually get that cumulative sum of the total for each year. Another thing is chart like this. And then like I have for example, let's say like a date or something. And when you have this, I'm going to just filter this information, just there's too much going on. Let's say like focus on the last year, 2020. And then it's hard to see the trend, right? So like you can draw the trend line, but there's another way to understand sort of like overall trend. So what that means, from the window calculation, either way, this quick window calculation give you the result quickly, and then you can modify the more detailed configuration. So underneath, there's a moving average. And this one, what it's doing is bracket 7. So that means this is like 7 days average. If this one is aggregated by the week, then 7 weeks average. And you can change it, the window size. But now this way, you can see sort of like an overall trend. But not only the trend, you can mix with the original sales information. And then, so now here, so like original is like an orange. And then, but if I get the average for every single 7 days period, and then like you get this blue color. Okay. So that's the moving average. Okay. There you go. That's the data visualization piece. And then I have done the data visualization workshop in the past, basically the series of the online seminar. So if you are interested in more about how you do the data visualization, not just the time series data, then I recommend you to take a look at this one. And you can go to the online seminar from our homepage, and then you can find that a visualization workshop. Okay, so let's quickly move to the analytics. We have 20 more minutes. I'm not sure like we have enough time, but this is a forecasting with profit. Okay, so forecasting is all about like you have the data, which is the actual data, and then you want to forecast for the period in basically the future that you don't have data or you don't have answers. Okay. And then in Exploratory, there are two time forecasting. One is profit, the other one is ARIMA. ARIMA is a very traditional way of approaching the time series forecasting. Profit is more modern way of approaching time series forecasting. And this one is pretty easy to use. This algorithm think the time series forecast as a kind of curve fitting. You have the original data and how you can fit, draw the line to fit with the original data by extracting the trend of yearly trend or seasonality or weekly seasonality, and also the overall trend and so on. Okay, and this algorithm was built by Sean Taylor, who used to be working at the Facebook, and also his other team members. What this one does is it is an additive model, and then therefore, based on the actual data you give to this algorithm try to understand what is that growth overall trend, seasonality, and also if you have like holiday kind of information, what is the holiday effect? And if you have the external predictor, which is I'm going to talk about a little bit later, and then what is the trend of those, right? And then by using this information, the goal is to fit the curve to the original data by using these for components, and then summarize them together to draw the line, and then make sure that line is going to fit as much as possible with the original data. Okay, so let's just take a look at it instead of keep talking about it. So here's a sales data. By the way, what we're going to do is basically something like this. This is under the chart view for now. So this is nothing to do with profit. I wanted to tell you, show you what I am going to do. So see here. So this is a line chart. So this is the actual data. And then I want to create a time series forecasting model to fit this data. Therefore, in the future, we have the only data up to 2020, but I want to see like how that trend is going to be like in the next year, 2021. Okay, so go to the analytics and then create a new analytics. And then here type, I can select time series analysis, and there's some profit. This is the one like you want to select. And the date, time, and then any level. In this case, let's say like weekly sales. That is the one that I want to select, forecast, and select the sum of sales, and click run button. And this will give me basically this profit, build a model, trying to draw this orange line to fit with the blue line, which is blue is the actual data that we saw in the chart view. And by trying to extract the overall trend information, yearly seasonality information. Okay, so what the overall trend information is here, when you go to the trend tab, this green line is a trend. So the profit thinks that seems like this line sort of like the overall trend is kind of going like this, kind of upward. And then when you see this red color, this is like a change point. And so it thinks on these points, the trend change. How much trend change is like a total change. This is like a ratio. So for example, when you see 0.02, that means a 2% the trend change. Okay, at this point. So therefore, this green line is not straight. You see like a little curve, and it's kind of like a change around here. So it seems like from around like 2019 to 2020, the trend change. Okay. And with also, when you go to the yearly, this is the yearly seasonality. So that this means like every year, this pattern is being repeated. Okay, so 2017, 18, 19, 20, you can see this pattern repeatedly. And what that pattern is from the January to May, seems like compared to other months or other weeks, other period, it seems the sales volume is lower. But then it goes up around June and it goes down around July and it goes up around like August. September goes down, October goes down, but then the rest of the year goes up. And this is the seasonality that being repeated every year. And that's the trend that Prophet detected. And Prophet thinks that's the value useful to fit the forecasted line to the actual data. Okay. And what it's here, we go to the effect. This is what you kind of you see additive is happening. So the green is the overall trend, the one like we saw in the green color before. And then this is the yearly seasonality, the blue color. When you combine this green and then blue, that becomes this gray line, which is the forecasted values. And this forecasted value is the one you are seeing as orange line here. Okay. And it seems like it's matching with the original data, but that's not really the point. We wanted to forecast in the future. And we see forecasting period is only this much. And that's where like you go to the property and the forecasting time period is right now 10. What 10 means? 10 weeks because aggregation level is weak. Well, I want to forecast for the whole year of the 2021. And the whole year is like basically 52 weeks, right? So 52 to 53. So I'm going to set 52 to make it like a whole year. And then I can click on apply button. So now this is like a whole 2021. I'm forecasting based on this time series forecasting model. Okay. And it seems like the beginning of 2021, the sales is kind of like not that high, but then like around like June, you remember the yearly seasonality is working here. So like from June and it goes down to July, and after that goes up. Okay, so that's the like the Prophet think it's going to be based on the trend in the past. Okay, and then so now here's another thing is when you have another data, let's say like here. There's for example, here, the sales comp or marketing cost or discount, and these are somehow is a character. Again, it's kind of annoying. Oops, what's going on here? So marketing cost, sales comp, these two should be numeric. I'm going to just change that data type quickly. There you go. So these marketing costs, sales comp, and discount. And I've been wondering if maybe these three are correlated with sales. Another means, I don't know how these like a marketing cost, sales comp decided, but maybe based on the sales comp is a sales compensation. Like, hey, like if you sell this iPhone, that you get 20% bonus or something like that. Marketing cost is like, how much advertisement you're doing for the particular product. And then you kind of allocate it for each order. So maybe if the sales comp or marketing cost is correlated to sales, that means that's a good indication. So if you know the sales comp or marketing cost ahead of the time, let's say next 6 months, this is the marketing budget, this is like how much we're going to spend, then maybe I want to include that information to the forecasting model. Then like we can, maybe like more precisely, accurately forecast how the sales is going to look like, right? So that's something I like to do here. That's where like this external predictor is all about. I'm going to change the pin button so that I can use those marketing costs and sales comp. And so external predictor, I can select this one, marketing cost, and here's a sales comp. More kind of easier way to explain this is like, hey, maybe like sales goes up when the sunny day and the weather is sunny compared to weather is rainy, right? So in that case, you can include those information as well if you have that as a data. And then let's say like next 10 days, next 30 days forecast. data, like if you have it, you can include it. Then you can see like how that sales is going to be considering that weather information. Okay, but this case, we don't have the weather data, but we have the marketing cost and sales comp information. So I added those as external predictors and I click the run button and how that is going to be. And here we have, seems like the orange line is more matching with the blue line, right? So basically at this time, what is happening is going to the effect. It is not only using the trend and the yearly seasonality, it is also using marketing costs and sales comp trend in the past as well. And then combine all these information to forecast this gray line or to draw this gray line to match or fit with the original or actual data. Okay, and when I go to the importance, this model thinks the sales comp is most important in order to forecast the the sales. The marketing costs the next. That means the sales comp is more correlated to sales. And then like, it is using yearly, but most of the stuff is actually decided based on the sales comp and the marketing costs. So if you can know the sales comp and the marketing costs ahead of the time, then this will help you to forecast the value more precisely. However, maybe like you don't, then, still like this is useful because you can see, oh, these are the ones that are very correlated with the sales. So, like I can, I should think about, how to do the sales compensation. And maybe like I should gear in towards the more sales compensation than the marketing costs and so on. Okay. So there's that. And then you can see under the summary view, you can see the model, sort of like a prediction quality as well. So this one is, I went very quickly, but if you want to know more detail about this time series forecasting, go to our homepage under the line, go to the how-to, and then how-to page, left-hand side, click on the time series forecasting. Then it will have, it will show you all the information about the time series forecasting. I have done the online seminar in the past, so you might want to check in that as well. Okay, the last topic is the time series clustering. So when you have the data like left-hand side, like this one is the mobility data, I think. Let's go to quickly the demo side. We had this, you remember that we had this Apple mobility trend data, and then we just visualize it like this. Okay, and then now let's say maybe like weekly or something like that. And then like when you have, I'm going to bring the state information and all the value to that color and something like this. And then this is cool, like, okay, like, each state has a different trend, okay. But don't you wouldn't that be great if you can kind of group of these states based on, how that, up or then going down, sort of like a downward, based on the trend, basically. Maybe some of the states are going up at the same time and then going down at the same time compared to other states, right? And then some states maybe not really going up and down. So those are the things we want to see. So that is, you want to go to the analytics view and then go to time series analysis. And then there's a time series clustering. And then group, I got to move the pin to the last one because otherwise the data type is messed up. So then here, group, I'm going to select the region, which is a state, and then date column. And then how I want to group by. Maybe I'm going to select like maybe week or something. And then the value to be maybe like let's say like average or something. So like weekly average. Okay. And then at this point, I'm going to click on run button. And it will try to find a similar pattern of the data. Right now, I have like 3 groups. I can change that to like 5 clusters or 5 groups. And I click run button. So now, based on the trend, it divided into like 5 different groups. I'm going to change that to columns, 3 columns. So like now 3 columns at the top, 2 columns, 2 charts at the bottom. So it seems like these are kind of separated into different groups based on the similar trend. So at this point, though, it's here the time series normalized. By the default, it uses a normalized value of each value. What that means is normalized meaning original data. When I go to the chart, so this is the original data, right? So this is like a percentage, and then some state has way bigger values than other state. So it's normalized basically by calculating standard deviation and then divided by that. Then all the states can be more like considered based on the normalized value, meaning like based on the trend rather than the actual or absolute values. Okay. So, but in this case, this is like a percentage data. So it's the default, the first is like 100% supposedly, and then 20% up, 40% up. So it's very similar data. So I like to do not just the trend, but also the closeness of each value. Okay, so like if like some states maybe like less than 20% range, up plus minus 20% range, I wanted those states to be in the same group. So what I want to do is go into the property, scroll down, and there's a normalization section. I'm going to set to the false. Okay, so in this case, then it will basically use the kind of like original value to cluster. So therefore, all the groups in the same cluster tend to have like very similar values. Okay. So sometimes the percentage data, this is probably like you want to disable the normalization. But when you have, let's say like a sales data, okay, and then maybe like United States sales is like super high values compared to maybe like some like Latin American countries, sales values maybe like lower. Then but the trend, let's say like the same, like let's say like March going up and April goes down, like May goes up or something like that. If you want to focus on those trend, then you want to normalize it. If you want to focus on the trend, but not just a trend, but also the value, the closeness or the distance of the value, then you want to disable the normalization. Anyway, so here now I have 5, and then it seems like number 1, it's kind of going down right after the lockdown season. And after that, basically keep going up. And then, now it's way back, way up. And then this one, 3 group, and these states seems like a way going up in the last summer and come down, and then like going up this year, this summer as well. So they really going all, free in the summertime. And then other states, like for example here, like cluster 5, these are the states. Seems like basically traffic is not really even going up. There's a change between based on the seasons, but not really going up. So you can see the closeness of the trend, but also the value itself, and then separate it. And then you can get, maybe like, oh, these states are similar states and so on. So when you go to the members, for example, and you see these are the states, kind of like similar states, okay, in terms of the trend. And then once you get this, here's the export button. This is what I actually do often is like you can select the save pivot, not the pivot table data, here time series data information. Well, yeah, either way, you can export the data and then create a new data frame. Then that way you can flexibly visualize. For example, one of the things you could do is something like this. So once you create a new data frame, then you can visualize by using a map and then see, all those clusters, maybe let's say cluster 3, cluster 2, are they closer area in terms of region? Or maybe not. Those are the things you can find out as well. Okay, so that's it for today. So the future online seminar, you can find, go to our homepage under the Learn. You can go to online seminar, and then you can see like future upcoming seminars as well as the past seminar recording as well. Okay, but the next seminar is I'm going to do is visualizing the confidence interval. And then there are many product improvements over the last few releases. So like I like to refresh what the confidence interval is and also show you many ways of visualizing this. Okay. And then other than that, today's I cover a lot of different topics, but you go to our homepage and then you can find a lot of how-to tutorials and the video as well. So I recommend you check those out. with that, and that's it for today's seminar. And then if you have any question, please feel free to reach me out by kan@exploratory.io, or we have the Exploratory Data Twitter account. So please follow, and so that you can get the latest news from us. Okay.